guys, today we are going to talk about the properties of logarithms. So there's four basic logarithm properties: the product rule, quotient rule, power of power rule, and change of base formula. The main ones that you're going to need to focus on are going to be these first three right here. The change of base formula is something that you can use whenever you don't have a log base button on your calculator, but most TI-84s have the log base button, so you don't have to use the change of base formula. I'm also going to post, or I think I already posted, a logarithm calculator where you can type in that base. So the change of base we're not going to worry about too much. However, the product rule just says that if you have log base something with two things being multiplied together on the inside, then you can expand it by having log base of the first thing plus log base of the second thing. Or if you have two logs with the same bases being added together, you can combine them by multiplying what's in the parentheses. The quotient rule is really similar if you have log base something with something divided by something, so like x divided by y or m divided by n is what we have in here, then you can separate them out by having log base of the numerator minus log base of the denominator. Or working backwards, if you have two logs with the same base that are being subtracted, then you'll take the first one and put it as a numerator and the second one as a denominator and one log with that base. And then the power to a power rule just says if you have a logarithm and on the inside you have something raised to a power, then you can basically just grab that power and move it to the front and it would be multiplied by your logarithm. So where you have log base b of m raised to the p power, you can just pull the p out front and you would have p times log base b of m. So I'm going to start by doing just a few basic examples where we're rewriting these logarithms. So I know that you guys can see this would be the same as log base 2 of 4 times 8, which is 32, but I just want you to see like how you would expand that if these were like variables instead of just 4 times 8. So you would have log base 2, and you're going to have whatever the first thing is, and then it's going to be plus log base 2 of the second number. So that's how you would expand those. They're being multiplied inside the logarithm, so you would add two logs of the same base together to expand it. The next one is the quotient rule. And so for this one, you would have log base 3 of the numerator, and then the division, whenever you're expanding it, is going to become subtraction, and you would have log base 3 of the denominator. And the last one is going to be the power of a power rule. So in this one, you're just going to take that 4 and move it to the front. So it would be 4 times log base 9 of 3. So that was just an example of the basic rules, but sometimes you're going to have to expand or condense something that's a little bit more tricky. So we're going to start with this log base 2 of 8 to the 4th power divided by 4. And again, we're just using numbers, but this is just like examples, and you would need to be able to do this with like variables as well. But either way, so we have log base 2 of 8 to the 4th divided by 4. So first thing I see is the quotient rule. So I'm going to separate this out by having log base 2 and then of 8 to the 4th. And then it's division in the logarithm, so I need to subtract another logarithm of the same base. And I'm going to put my denominator in that one, and that one's going to be 4. So the only other thing that I can do is I also have the power of a power rule right here. And so I can bring that 4 to the front. So I would have 4 times log base 2 of 8 minus log base 2 of 4. And that would be my final answer on that one. And so then I'm going to come over and work on this log base 3 of 4/5 squared. So the first thing in this one that I see is the power to a power rule. So I'm going to pull that 2 to the front. So I would have 2 times log base 3 of 4/5. And so then with the 4/5, that's where the quotient rule is going to come into play. So I'm going to break that down, and I'm just going to put this in parentheses for right now because I want to break down just the log base 3 of 4/5. So I'm still going to have my 2, and then I would have log base 3 of 4 minus log base 3 of 5. And so then the only other thing left to do is just to distribute that 2 to both of the logarithms. So I would have 2 times log base 3 of 4 minus 2 times log base 3 of 5. So just don't forget whenever you're expanding in that scenario that the 2 from the power to a power rule would apply to both sets of logarithms whenever you're expanding because of the quotient rule. So another scenario that you may come across is where you need to condense 2 logarithms down to one single logarithmic expression. So we have log base 4 of u minus 6 times log base 4 of v. So right now I can't combine them with the quotient rule quite yet because we have this 6. So I kind of need to work backwards with the power of a power rule and put that 6 back up in the exponent. So I would have log base 4 of u minus log base 4 of v to the 6th power. And then you can put those in parentheses if you want. And so then at that point, what you need to do is use the quotient rule because you have 2 logarithms, both base 4 and both with coefficient 1. And so now you can use the quotient rule and just put the first one in the numerator and the second one in the denominator. So you would have log base 4 of u divided by v to the 6th power. In this next one over here, we have 2 log base 3s, but they both have coefficients other than 1, so I'm going to want to move both of my coefficients back up to my exponents. So I would have log base 3 of u to the 4th minus log base 3 of v to the 20th. And then I can use the quotient rule again and combine these. So it would overall be log base 3 of u to the 4th divided by v to the 20th. So then this is a type of problem that you may see like on a homework or a quiz or a test or something like that, where it's a little bit more challenging than that, where you have a lot going on and you need to condense it down to just one log. So I'm going to go ahead and start, and I have things in parentheses that need to be like distributed out. So the first thing I'm going to do is distribute my 2 into both of those logarithms and distribute my negative into both of those. So I would have 2 log of 2x minus 2 log y minus log 3 minus 2 log 5. So then the next thing that I need to do is anywhere that I have a coefficient other than 1, I need to move that back to my exponent position. So I'm going to have log 2x, and then the 2x is going to be squared, and then it's going to be minus log y squared minus log 3, and then minus log 5 squared. And then there's a couple of different ways to go about it at this point. You can just combine like the first 2 and then start adding stuff in if you want to. And so that's the method that I'm going to use. So if you're combining the first 2, then you would just use the quotient rule, and you would have log of the 2x, that whole thing was squared. So that would be 2 squared and x squared, so it would technically be 4x squared. and then minus log y squared, so that means that the 4x squared is going to be divided by y squared. So at that point you have those two combine into that, and then minus log 3 minus log of 5 squared. So then if you need to subtract another log 3, then it would be like 4x squared divided by y squared, and then that whole thing needs to be divided by 3. And so the way that you go about that is that 3 is going to join the y squared in the denominator. So to put those two together, you would have log 4x squared over 3y squared, and then minus log 5 squared. And then the 5 squared is the only thing that still needs to be added into that denominator. So we would have log 4x squared on top divided by, and then you need 5 squared times 3y squared. So 5 squared is going to be 25, and then that 25 times 3 is going to be 75y squared. So everything that we had up here, those 4 different logs are going to all combine into log 4x squared divided by 75y squared. And now on this one, it's kind of working backwards from the last one, where you have to expand this one logarithm completely out as far as you can. So I'm going to start with the quotient rule, and I have a circle. Sorry about that. So I'm going to start with the quotient rule, and I would have log base 6 of the numerator, which is the 5th root of x cubed, and then minus log base 6 of y to the 9th power. So there's definitely going to be some power rules going on here. The first thing, just kind of like a side note that I want to put over here, if you have the 5th root of x, and that is supposed to be a 5 on the outside, I'm not sure what happened to it, but if you have the 5th root of x, then that's going to be the same thing as if you have x to the 1/5 power. So then if you have the 5th root of x cubed, then it would be the same as like x to the 1/5 power, and then you would have to add that 3 in. So it's going to be like x cubed, which would, it would be like x to the 3/5, because you would have x cubed and then the power would be times 1/5. So then like the 3 times the 1/5 is going to give you 3/5. So that's something that you guys should have done in a different math class at some point. But I just wanted to review it real quick. So in this first logarithm here, you would have log base 6, and then that x cubed, or the 5th root of that x cubed, would be x to the 3/5 power, and then minus log base 6y to the 9th. And so then at that point, that's where you need to pull all of your exponents and move them back to the front to be multiplied by your logarithms. So in the first one, you would have 3/5 times log base 6 of x, and then minus 9 times log base 6 of y. So then that would be all on that one. I meant to say, so whenever you're expanding completely, to expand completely, you need to make sure that none of your variables inside the logarithms still have exponents on them, because you're going to want to bring those down and bring them out to the front. So then now, because we have those log properties that we can use, we can actually solve something like this, where you have 2 separate exponentials set equal to each other and they don't have the same base. So these are going to be like some of the most challenging and advanced types of problems that you'll see. But you should be able to solve them decently well at this point with what you have with log properties. So the first thing is, I just want to rewrite the left-hand side into a logarithm. So I have 4 to an exponent, and it equals something on the other side. So if I'm rewriting it as a logarithm, Then I would have log base 4 of all the stuff on the other side. So 3 to the 2x minus 1. And then all of that is going to be equal to the exponent, which is 3x plus 2. So then the first thing that I'm going to do is I'm going to use my power rule, and I'm going to pull that exponent out to the front. So I'm going to have 2x minus 1 times log base 4 of 3 equals 3x plus 2. So then at that point, this log base 4 of 3, that's really just a number. And I'm not going to actually calculate what that number is yet because I don't want to round at any point during this. So the first thing I'm going to do is distribute that log base 4 of 3 times the 2x minus 1. So even though it's written after it, I can still distribute that number into the 2x minus 1 because it's still being multiplied. So I'm going to have 2x times log base 4 of 3, and then minus 1 times log base 4 of 3. And then minus 1 times log base 4 of 3 is just going to be minus log base 4 of 3. And then all of that is going to still equal my 3x plus 2. And so now at this point, I just have 2x times some number minus a number equals 3x plus 2, which is just a number, obviously. So what I want to do at this point is I want to get all of my x's on the same side. And then I'm going to get my numbers, which are this log base 4 of 3 and my 2. I want to get that on the other side. So I'm going to start with my 2x times log base 4 of 3. And I'm going to pull that 3x over, so I would have minus 3x. And then it's going to be equal to, and I'm going to get rid of this minus log base 4 of 3 by adding it to the other side. So it's going to be a positive log base 4 of 3 plus 2. So then at this point, I have all of my x's on one side and all of my numbers on the other side. So the whole right-hand side is just a number right now. It just looks more complicated than that. So the next thing that I'm going to do is I'm trying to get x by itself, and it's in both of these terms now. So what I'm going to do is I'm going to factor an x out to the front. So I'm going to have x times 2 times log base 4 of 3 minus 3 because I factored that x out. And then all of that is going to be equal to log base 4 of 3 plus 2. So then now I just have x times a number equals a number on the other side. So the only thing left that I need to do is divide by that number that's being multiplied by the x on both sides. So I'm going to divide by 2 log base 4 of 3 minus 3 on both sides. And then I'm going to need to calculate all of this. So I've got my calculator pulled up, and since that's a really long thing and I don't want to deal with making sure all the parentheses are in the right spots and everything, I'm going to hit alpha y equals, and I'm going to choose that little n/d. It's like numerator over denominator, and it just puts a little fraction bar in here for me. And then the numerator was log base 4 of 3 plus 2. So to get that log base, I'm going to hit math up, and press enter. My base was 4, the inside was 3, and then I'm just going to press over to do plus 2. And then the denominator was 2 times log base 4 of 3, and then minus 3. So math up again. And then the base was 4, the inside was 3, and then on the outside we have minus 3. And that gives us negative 1.97 as our x. So then I had x equals all of that big number that's in the brackets, and that worked out to be just negative 1.97. And then I also just wanted to show you another way that you could solve this type of problem if you weren't going to solve it out by hand. I want you to know how to solve it out by hand, but in case you get stuck and you're like not sure where to go at some point during that process, you can, as almost always, use Desmos. So the left-hand side of our equation was 4 to the 3x plus 2, and the right-hand side was 3 to the 2x minus 1. So just make sure that you type those in separate equation spots on Desmos. And whenever I typed it in, this little gray dot around negative 2 popped up. And if I just click on that dot, it gives me my intersection point at negative 1.97, which is what we got by working it out by hand as well. So just know that if you get stuck in this long process and you're not sure where to go, then you can use Desmos to graph it as well. And that pretty much sums up log properties, and this is going to be your homework, so it's going to be a lot of solving equations and using those properties to expand those logarithms. So I wish you luck on this. I know some of them look a little bit tricky, like number 52, but I think you guys have got this, and let me know if you have any questions.